Okay, I've already written number 32 up here, and the instructions say to solve the following equation and explain each step. Okay, I'm not going to write out the explanation, but I'll talk about it. That's it. Just solve and explain. So this is a rational equation. What do you need in a rational equation? Common denominator. So the nice part about this one is, A, it's already factored. If it wasn't factored, we'd have to factor it. But it's already factored. So what does this denominator need? X minus 1. So I have to give that to the numerator as well. What does this denominator need? X minus 3. And what does this denominator need? Nothing. Once I have the same denominators all the way across in an equation, what can I do? Cross them out. And then we'll just solve what's in the numerator. So 3 times x minus 1 will become 3x minus 3. Then there's our equal sign. 1 times x minus 3 is just x minus 3. And then there's our plus 7. And we'll just solve this. So we got to get our x's all on the same side. I'll subtract this x over. So that'll give me 2x over here. But I'm also going to get rid of that minus 3 at the same time. I'll add that 3 over. So on the right-hand side, I have negative 3 plus 7. So what is that? Just 7. Negative 3 plus 3 cancels, then plus 7. And then I divide both sides by 2. And x equals 7 halves, or if you like the decimal, 3.5. What else do you have to do with rational equations? Just like you have to do with radical equations. You have to check. Because it is possible that we get something that when we plug it back in, would give us an undefined. Look back at the original. What numbers would give us undefined because they would make the denominator 0? A 3 we would have to reject, and a 1 we would have to reject. As long as we didn't get a 3 or a 1, we are okay. We can trust ourselves that that's the final answer. So x equals 3.5, but if by chance we got a 3 or a 1, we'd have to reject it. Okay? You have to check pretty much everything other than a linear and an exponent, or a linear and a quadratic. Linears and quadratics, typically you don't have to check your answers other than for accuracy, obviously, but you won't get an extraneous root with those two. But any other type of function that we're ever solving, logs, radicals, rationals, exponentials, you want to check for extraneous solutions because there are certain numbers that make those undefined, and you have to be careful of that. Okay? All right, 36, copy this down. It's phrased a little bit differently. It says use long division to divide this by that. I trust that you know how to kind of turn that into long division. So we're going to start with that because that's what it says, but then I'll give you the follow-up questions in a minute. So to review long division, we start. X goes into x cubed how many times? Or, in other words, x times what gives you x cubed? X squared. And then once I put that up there, I take that and I multiply it by this entire binomial out in front and line things up appropriately. So I have x cubed plus 2x squared. And I do subtraction. So x cubed minus x cubed cancels. 7x squared minus 2x squared is 5x squared, and then I bring down the next term. And I repeat, x times what gives me 5x squared? 5x. Positive 5x. And then I multiply that 5x by the entire binomial out in front and line it up. So 5x times x is 5x squared. 5x times 2 is 10x. And I throw my little subtraction signs in there. 5x squared minus 5x squared cancels, as it always should, if I picked the right number. 14x minus 10x is 4x. Bring it down. Repeat. X times what gives me 4x? 4. And I repeat, I multiply that 4 by the binomial out in front. I get 4x plus 8. Do my subtraction. And 3 minus 8 is negative 5. So, to write this, remember this is where I put my remainder, my negative 5, over the x plus 2 divisor. So that would be my final answer, x squared plus 5x plus 4 minus a 5 over x plus 2. Why do we do long division? To see if it's a factor. Is x plus 2 a factor of this?
No.
No, because why not?
Because it's the remainder.
Because we got a remainder other than 0. The only way it's a perfect factor is if it goes in evenly. And you'll know if it goes in evenly because you'll have a remainder of 0. This is not a remainder of 0, so this does not go in evenly and is not a factor. Okay? And that was the second part. Is x plus 2 a factor? Explain why or why not. It is not a factor because there is a remainder other than 0. Okay? So, Hunter said that was one use of long division, is to see whether or not something's a factor. How about sometimes we do long division when we know something already is a factor? Long division is the least efficient method, but it's still a method of factoring. Okay? Because if this had gone in evenly, let's pretend that wasn't there. If this had gone in evenly and gave us that, then we would have been factoring this into this times this. And then we could continue factoring the quadratic by hand, by our guess and check methods, to get that this whole 4-term polynomial factored into x plus 2 times x plus 4 times x plus 1. Okay? And we've had to do that before. They ask you to factor something like this that's not groupable, and the only way to do it is by long division and dividing out the factor that they told you about. Okay? Underneath 32, going back here a second, I want you to write a new example. I want you to write 3 over 3 minus x equals 1 over x minus 1 plus 7 over x minus 1 times x minus 3. It's almost the same problem that we did. Hold on, wait for it to focus, there we go. But what did I change about it?
You flip the thing around.
I flipped this one around because this has come up, and I'm not sure we would know how to handle this.
No, we don't.
Because these are not technically the same, are they? Okay? If I want to make them the same, what do I have to multiply this by to switch the order? Jacob? Negative sign. A negative 1. So if I multiply the denominator by a negative and the numerator by a negative, that's going to change the problem to negative 3, and then I can just, instead of using the negative on the bottom as well, I'm just going to flip that 3 minus x to x minus 3. And then I can carry on like I did before. Is that clear? Okay? So if that comes up, and the denominators are pretty close to the same, but this order of subtraction is flipped, you know you can just multiply one of them by a -1 to flip the order back around the way you like it, okay? If one of the denominators is x plus 1 and the other one is 1 plus x, do we do the same thing? No. We don't need to change those because x plus 1 and 1 plus x are the same thing. Adding in either order is the same thing. Subtracting in either order is not. Okay, and so with the subtraction we have to flip it around. Alright? Okay, so on the next example that I want to do is, I'm going to jump to test 2, number 21, because you won't get to that in your homework. Here's 21. You guys aren't going to be able to write much down here. So let's just go over this together. K of x, you see the line K of x, passes through points A and B. Where I see, okay, here's A, here's B. Its equation is written in the form y equals mx plus b. So you tell me, what's the equation of this line? Y equals, what's the slope of this line? If I ride 1, 2, 3, 4, 5, 6, 7, 8, 9, and I run 1, 2, 3, 4, 5, 6, 9 over 6, 3 halves. What's my b here? -3 is my y-intercept, okay? Okay. How would the equation of that change if point B were translated 3 units down? So I'm going to change colors here. A is staying the same. B is being moved down 3 units. So now I'm connecting these two. So what happens to my slope? Now my slope is ride 1, 2, 3, 4, 5, 6. Run 1, 2, 3, 4, 5, 6. 6 over 6. So now my slope is 1. And what's my y-intercept? Looks like it's -4. I would just want to make sure up 1 over 1, up 1 over 1. If I had a perfect straight edge, I wouldn't have to worry about it. But because I kind of freelanced that, up 1 over 1, up 1 over 1, it is crossing at -4. So what's the answer? Did m decrease by 3? No, the slope was 3 halves, so that's 1 1/2. The slope only decreased from 1 1/2 to 1. So it only decreased by 0.5. And did the b decrease by 3? No. M remained the same? No. M decreased by 0.5, and b would decrease by 1. Okay? Weird to me. This is an Algebra 1 question, but I did see on the January revision something that was like a linear function, and I was just shocked because it's not really what I taught you. I didn't teach you lines. You should have already known them. But. So your homework again is up here. It's online. You obviously have to go online and get test 2 anyway. You know? All right. Oh yeah. Well, yeah. Sure. Because I did already go down to that. Thank you, Riley.
Wait,
The weekend.
Yeah.